Okay, I'm not being willy-nilly. I'm going to put in the two capacitors. We'll start the setup with the restrictions. That'll avoid the problem. See if the hum goes. If the hum goes, we'll cut the old capacitor free, and hopefully the hum doesn't return. It shouldn't return. That's the plan of action. Okay. I got it. I'm going to do it. Okay, bit of easy success right away. So from this yellow wire terminals here, yellow wire comes along, comes all the way to this terminal. Then there's another yellow wire that goes from here on this tube all the way around to here on this other tube. These are the two output tubes. This terminal is terminal number, if we count, here's the gap, 1, 2, 3, 4, 5, 6, and 7. Pin 7 of an output tube. So if we look, it may be very hard to see on the camera. That's pin 7. There's another pin 7 up here, of course, and that's right to the screen. And this wire, or line on the schematic, I should say, it's not a wire, it's a line on the schematic, straight to one of these. Okay, so this one has to be this one. One done. Now I've got to sort out the other one. I mean, there's a capacitor here, and the red wire goes to the capacitor here. Surely I can find where these are in parallel on the schematic here. Or I'm busily tracing, yeah, lots of red wires in this radio. This wire, let's keep doing this. Just underneath there, just coming around. It is so easy to get this wrong. Okay, comes along here. And for crying out loud, goes down a hole in the chassis and disappears onto the other side. Really? That's not going to help me. So this other wire here disappears in a hole. That's a strong indication that these two wires go topside to reach the output transformers. That's one possibility. And then these guys, this would be energized by the wire coming from the other capacitor. Now the other capacitor would need to be another wire in here. I wonder what a good way to do this would be to trace out this wire from the rectifier. I want to get a look at the rectifier anyway and see what it is. And that would lead us to this. Yeah, that's a good idea. I like that. Who got that idea? That's a good idea. Where is the rectifier? So usually the rectifiers are of a type that needs to be, that develops a bit of heat, so they usually have it arranged so the heat is being sunk into something. And it's probably up on top. This is interesting. This is a band, I'm sure, was put in to clamp down something. It's not clamping down anything. See, here's one over here. Here's one here. What's not being clamped down? And right beside it is an electrolytic capacitor. So if I flip it over, I'll be able to get a look at the red, the wires going up through here. Maybe. It's so cluttered. This radio is so cluttered. Yeah, where is the rectifier? Okay, I gotta flip this thing over. It's easier said than done. Yeah, right. Down there. Rectifier. Looking for the rectifier. It's going to be somewhere around here. Looking for a rectifier. What exactly does it look like? Looks like a little, what a little pack of 5 cigarettes would look like. adjustment I discovered underneath. Now, you know what? It's not beyond these radios to have long wires leading far away. So that component I'm looking for could easily be anywhere. It could be anywhere in this radio, really. Okay, there's no hint of it here. Maybe it was down at this end and I didn't look hard enough. Okay, I'm going to flip this radio back over. Even harder. Okay, steady again. Here, down at this end, something a little suspicious there. Maybe too many terminals on it. Okay, I'm looking around where you're not. Where are you? Well, the hunt's going to continue for a while here, so we're going to, when I find it, I'll show it to you. Okay, I'm quickly coming to a conclusion here that this is actually the rectifier inside this round tube, which I've never seen before. The rectifier must have 4 terminals on it. Although one of them can be hard to spot because it could be 3 terminals and this ground terminal is kind of hidden in the can somehow, if you know what I mean. So there could be 3 or 4 terminals. The capacitor should really only have 2 terminals, assuming this is a shared capacitor. 2 terminals plus a ground, and the ground could be the shell. This guy's got 2 terminals. And we know the shell has been carefully grounded. This guy here, he's got 4 terminals. Let's take a look at that with a close-up camera and be sure. It looks like 4 now. Funny how you look at these things again and again, they look different almost every time you look at them. So what do we see there? We see we need a little more light. Well, sure looks like 4 terminals. 1 clearly is grounded. The other ones, each one of them has a wire coming off. It's just very hard to see. I think this is the rectifier here. And then what was in here? Was there? It sure looks like there was something in there once. In fact, if you look, it looks like some kind of disaster happened here. There's goop. There's goop here. Goop appears to have come out of this transformer, is where it appears to have come from. Well, I don't know. I mean, I can make up all kinds of stories about what may or may not have happened here. Sure looks like something happened. Goop all up here too. There's goop everywhere. Okay. Okay. So if I go with that being the rectifier, then I need a counterbalancing proof. Counterbalancing? I know. I need supporting evidence. Is what I need. I need some supporting evidence that that's a rectifier. Then this would be the wire I was looking for. That's coming from the rectifier. It's attaching to the it's coming across attaching to the 100, and from the 100, it's going up. It's going to meet with this tap into the output transformer. It's got a capacitor here, tap, transformer, through a capacitor onto the plate. We already saw that this other side, the yellow side, comes up and attaches directly to these two pins here. Got to be the case. Got to be the rectifier. Got to be the filter capacitor. So we're back to this, and now we know, according to what I've worked out here, this is the 100 side and this is the 50 side. So now one way to prove that this capacitor is the cause of the hum is to simply parallel in, without removing this capacitor, parallel in additional capacitance here and here. My intention would be to get rid of the original capacitor. I don't want to do that right away, so I could do a permanent installation of the two new capacitors here, leaving this one connected, and then when I'm done, reach under with my cutters, after doing the test and discovering that yes, the hum is gone, reach under with my cutters and cut these terminals off, the old capacitor. What's the old capacitor going to do? So in all the years I've been doing this, I've only come across one case where a capacitor of this sort, power supply capacitor, was drawing, had such an internal leak. It was heating up, and it was heating up a lot. Definitely on its way to smoking in the long run. And that would produce a lot of smoke, I would think. Only had that happen once. So why not just leave this guy in here for good? Because the benefit of that, there's a reason for doing that. These terminals then are fixed in place quite solidly. If I put in some more capacitors and that, there's quite a bit of wiring here, they're probably still relatively solid in place. Even though I'm going to cut them and they'll be floating here. I could throw a little insulation on them, some tape or something like that. Make the leads to the two new capacitors short so they provide some holding power, but it's not a lot. And is there room in here? Like this part's sticking up above. Yeah, this adjustment is what's keeping this from hitting the bottom. It's sticking up. This is sticking up. Was this not right down on something? This is sticking up too, but it's a little loose. So there's lots of parts that are sticking above this level. So here's a bracket. I don't understand that. So is there enough clearance in here to put in some capacitors? Let's get a couple and we'll just check. I'll just grab a couple here. Okay, just without even thinking about their size or value. Actually they do. They hide just under this height. It's not really an issue. The radio must be up on something in the cabinet. I have to go look to find that out. Okay. Next step, install the two new capacitors, a 100 and a 50, as required on the schematic. Operate the set with this additional capacitance. Run a small risk of, let's see, this is basically an instant on in the sense that a rectifier is not a tube. You instantly get voltage there. Or there's an attempt to charge that capacitor up right away as soon as you turn the unit on. Well, I can do it with restriction. Right? I use my dim bulbs to restrict the power coming into the set. Because if you put too much capacitance here, there's a chance you're going to damage this rectifier. Not a great chance, but I mean, if you really want overboard. So what if there's still 100 and still 50 here? I'm totally wrong. The hum is from something else. There's nothing wrong with this capacitor. Now I'm going to double its size. Would it be in the range of damaging this? If this were a vacuum tube, there's a second problem of too big a capacitor can lead to too much voltage across the plate, which I can't explain in detail, but there is an issue there. Anyway, you can't just be willy-nilly about this stuff. Okay, I'm not being willy-nilly. I'm going to put in the 2 capacitors. We'll start the setup with the restrictions. That'll avoid the problem. See if the hum goes. If the hum goes, we'll cut the old capacitor free, and hopefully the hum doesn't return. It shouldn't return. That's the plan of action. Okay. I got it. I'm going to do it.